Now, from the previous example, we can see a way of classifying certain quadratic spaces using orthogonal splitting. Right, so let V be a quadratic F space. So it's a quadratic space, a quadratic module over a field. Then we can apply Gram-Schmidt and find an orthogonal basis for V. So let's say that the Gram matrix of the bilinear form of V has diagonal entries alpha 1, alpha n with respect to this basis. Now the claim here is that these alpha i's are only determined up to a square. That is, if we change alpha I up to a square of a unit in F, then that does not change the isometry class of V. And this gives us a way to classify the quadratic space V over different fields. So for example, over C, or any algebraic closed field, each alpha I is a square. Every alpha I is a square, so V is going to be isomorphic to this. Over R, we have two classes, so an element of R is either a square or it's going to be a negative element, so we have two representatives of the cosets of square. Similarly, over a finite field of odd size, then we also have two classes. Over Q, however, we have more than two classes because it's not true that the quotient of two non-square numbers is going to be a square. So the most we can say is that we can choose a square-free representative for each of the class. But now let us explain why these alpha i's are only determined up to a square. That is, changing them by a square doesn't change the isometry class. Let us review first why we do not necessarily have an orthonormal basis. Well, so we know that the so-called norm of Vi in this case is alpha I. And if we want to shrink Vi to get norm 1, we would want to divide Vi by the square root of alpha I. But alpha I does not necessarily have a square root, and that's the problem. In general though, we can shrink it by the closest to a square root. So let's say alpha I is up to a square is this. So alpha I is beta I squared times epsilon I. So the epsilon I is a representative, coset representative of alpha I in F star mod I by F star square of the square, right? So you can think of beta I as a closed square root of alpha I. Then if we take this in quote norm of Vi over beta I, what do we get? We just divide alpha I by beta I squared. So this is just epsilon I. And so we see that if we replaced in this basis, if we replace Vi by Vi mod I by beta I, then we can replace alpha I by epsilon I, which is a coset representative of alpha I in this F star mod F star square. So by an appropriate choice of basis, if we just shrink all these bases, we can replace the alpha I by their coset representative in F star mod F star square.